Hello everybody, it's Neo Driss here, and today we're going to solve the n queens problem, which is a hard problem to be honest if you at the first sight, but once you understand how to solve it, it's pretty easy. So let's start with explanation. So for the n queens puzzle, we have to place all the queens in the board of size n by n. For example, here is 4 by 4, okay, and we have 4 queens, of course. For board 5 rows by n columns, we have 5 queens, okay, and the limit I think is 9. The n is equal to 9. So we have 3 conditions for these queens to be, you know, not to attack each other. They have to be in the same, they must not be in the same row, they must not be in the same column, they must not be diagonal to be with each other. For example, this queen here must not be, like this queen here in the second row must not be in this spot here, this column here, okay, the third one. So it's not diagonal with this because it's going to attack this one. Should not be in the same row, so it doesn't attack this one. It should not be in the same column, so it does not attack this one, okay. So the most challenging thing, like, we know the rows, okay, we're gonna have a hash set or whatever we want, anything to store this value, the value of the cell in which we have the previous queens, to know if it is in the same row or the same column. We're gonna store the row and the column of the queens, and that's it. But the challenging thing, I think, for people who solve this problem is to know if they are diagonal with each other, in which we bring the characteristics of diagonal lines. For example, okay, I hate these ads. I really do hate these ads, sorry. For example, we have this paper here that talks about positive diagonal lines, negative diagonal lines, something that LeetCode talked about in his video, but here is more detailed if you want to check this out, this article in ResearchGate. So it talks about how the values are constant throughout the lines, okay. For example, this is a positive diagonal. Okay, I'm gonna zoom in a little bit here. So I hope you can see my mouse. This is a positive diagonal for where we have 0 here, okay. This is a positive diagonal. This is the second one here. This is a negative diagonal because it's going on the negative side, okay. So the right side is positive and the left side is negative, okay, of a graph, if you've seen one before. And as you can see, rows minus columns, here is 7, minus 7, sorry. In this, when it's the same diagonal line, the value of rows minus columns is always the same of all diagonal lines. Like, for example, here, this line has 0, 0, 0, 0, 0. This line, where we have like the second line, we have 2, for example, 2, 2, 3, 3, not 2, 2, no, sorry, it's 2, 1, 3, 2, 4, 3. It has all the same value of 1. And it's the same thing for all these lines, okay. And for the negative diagonal, it just changes to rows plus columns, pretty much, as you can see. So to check that, in our example, for example, if you place a queen in cell 1, 1, you just have to check, sorry, on the second queen is on, you just have to add like these positions. For example, you're gonna add this position, you're gonna add this position. You're not gonna add anything in the, sorry, just confused here, it's night. So for example, we place queen 1 here in position 1, 2, and the second one here. So this is gonna be in the negative diagonal set, so it's gonna be, ignore this. The second one here is gonna be in the positive diagonal set, so another positive in the same column, so it's gonna ignore it. Here is gonna be in the positive diagonals, it's gonna ignore it, so on and so on. Like, It's just going to be recursive calls. So let's start with the code. So I hope it's been understandable. So we'll start with a vector of solutions. Okay, we want a vector. Okay, so just before writing, so I'm going to say it's a list of solutions. Alright, so it's going to be a vector of strings. So it's going to be a vector of strings. Okay, and we need a vector of that, as you can see here in the output. So we need a vector of strings, also a vector of vector, in order to have multiple solutions if any. So we're going to have a hash set of integers taken columns. So we'll just say like, yeah, taken columns. And we're going to have the same thing for diagonal lines and negative diagonals. So we're going to say positive diagonals and negative diagonals. Okay, and we're going to have a vector where we'll represent the chessboard that we need, of course, because this is where we have the solutions that we want. So this is where we're going to print everything. Okay, and yeah, pretty much it. So the chessboard is going to be filled with just dots in the beginning. We're going to represent like empty spaces with dots. Okay, and the queen is going to be Q, of course. And if we have all the conditions satisfied, we're going to just add the queen to the row, the corresponding row and column that we want. So we have chessboard. I'm going to say it's chessboard. It's going to be of size n. Rows like that's the number of rows, and we're gonna have string, I think, yes, a string of also size n, since as you can see it's 1 2 3 4. So this is the number of columns. Sorry, this is the number of columns. So the string represents the columns pretty much, if you can understand it this way. I'm just gonna be full, everything is gonna be full of dots. Anyway, it's not really columns, just represents a string of 4 characters pretty much. That's it. So just to make you understand, because we're going to represent the columns with just values. So now that we have all of these set, so we have all these hash sets, all these sets set, we have a vector set. Now we want to create our recursive function that will keep checking. For example, we're going to put the queen here. I hope my mouse is visible. Yep, so we're gonna put the queen in the first spot, then we're gonna check this one, nope, this one, nope, then this one, yes. We're gonna put the second queen here, we're gonna check this one, nope. We're gonna come back to the previous row, then we're gonna again see this one if it works, and we're gonna check, and as you can see, it's the same thing again and again and again. Just you have to call again until you reach the endpoint, which is n+1. For example, if you call again the recursive function, you find that you are, for example, at 5 in this example, which means that that's it. You put the queen in the last row, and you again call the recursive function to access something that does not exist. So we return the results that we have. So we return the chessboard, and we add that chessboard into the list of solutions. I hope that's clear. So let's start with the recursive function. So it's gonna return an int. So I'll call it just backtrack equal. So it's gonna take as an argument an integer. Alright, so let's start with the if statement. As you can see, we have 3 conditions. If it is in the same column, break the loop. Okay, not break the loop, just like skip this iteration of the loop. If it is we skip it, just go back to the previous one. If you skip that, of course you're gonna get out of the scope of the function. I'll show you. So if we're just gonna write these conditions here, so we have if rows equal to column, right? So yeah, this is like the number of, yeah, so we input just the number, like we will give it as input the row as we said. So if it is equal, as I said, to the last condition n, so we're gonna return. Okay, so for now we're gonna keep it like that. So now we're gonna start looping. So for int, we're gonna start with the columns equals 0, c smaller than n, of course. Then we're gonna just c plus plus. Okay. So now we're gonna have these two conditions here. We're gonna have these three conditions. I forgot to add this first condition. Okay, it's okay. So if taken columns, so we're gonna do that count dot count. If it contains this current column, then we're gonna ignore. Then we're searching. Of course, at the beginning it's not gonna do anything since it's gonna be the first one. So let's do the same thing. We're just gonna change these to okay, or so we're gonna say positive diagonals. But as we said, positive diagonals is gonna be row minus column, and then a negative diagonal, it's gonna be row plus column. Alright, so if this is true, we're just going to continue. Okay, so we skip this loop iteration. So here we skip the loop iteration. Skip this loop iteration. Then we do what? Then we will, so for example, if this current column and this current row are not, you know, since we'll never, to be honest, I think we will never re-access the same row. Yeah, we'll never re-access, so we don't need this condition here because we will never access the same row. We always have like the recursive function going to different rows, so we don't need that, as you can see. So we will go to the next one. So for example, this one, all these conditions are true, so we're going to just call backtrack again and go to the next row. But before doing so, row plus 1, but before doing so we need to do what? Yeah, we need to store these new values that we just accessed. So we're going to say taken columns, I'm going to add to them the columns, taken columns. Of course rows, we don't need to do that. Oops, dot insert, sorry. Really. Alright, and then we're going to do the same thing for these. So we're going to do that. We're just going to copy paste that stuff here. Okay, positive diagonals, negative diagonals, and this is going to be minus columns plus columns, right? And the negative is going to be minus, right? Okay, I think I did a mistake here. Hold on. So this is the positive diagonal, this is the negative, right? Yeah, so positive is a minus, is a row minus, sorry, it's row minus, what? I thought G was the row. Yeah, G is the column, so it's row minus column. And the negative diagonal is the row plus, so yeah, I'm correct. Sorry about that, just my brain, lack of sleep. It's alright, I'm just learning stuff together, guys. So it's row plus this, so we're gonna add this, yeah, and that's what we're gonna check. So now we're gonna add the negative diagonal, the positive diagonal of the current queen that it was placed, and also its column, and of course the previous row is not the same. And then we're gonna keep doing that, backtrack, it's gonna access it again, then you're gonna find this. For example, if we found that either of these conditions are true, we're gonna continue to the next iteration of the loop, which means we're really like, we're gonna just check if there is another position that we can take. If not, it's gonna finish the loop, It's gonna return nothing. It's just gonna go back to the previous call. So if it goes back to the previous call, it needs what? So we need to remove what we did. Yeah, it needs to remove what? What we did. For example, it's just gonna exit from here. It's gonna continue here. Okay. When it refers to previous call, the previous call is gonna pop out of this place. Yes, okay. For example, if a previous call, like for example, we backtrack again, we come back to this function stack, it's gonna pop out here. So we need to do what? Of course, like the taken columns are not taken anymore, so we need to remove them. Yeah, so we're gonna do that. We're gonna do the same thing, and we're gonna do erase. Why did we do this, you want to say? So now we need to remove the positive diagonals because we're going to remove the queen from that spot, because that spot is not good, you know. Now we need to check again for the previous one, another new spot, and set again new positive diagonals, new negative diagonals, sorry. I think this is called, why did I put rows here? And then a new column, pretty much. So now I'm going to do I'm going to insert into the chessboard. I forgot to insert into the chessboard row, the column is going to say equal to queen. And here, of course, if we found no position where we can have for example, if we came back again, you know, we found no position where to put this, the second row, like we found no solution, we come back, we need to find another solution for the previous queen, another spot on another column, I mean. That's why we need to remove the previous one, and again it's gonna re-loop again. It's gonna go for the next iteration, which is the next position. Of course, it's gonna find nothing, and it's gonna put the new queen there, set its negative diagonals, set its positive diagonals, set its taken columns, and boom, go to the next row and see if there is another solution. Not another solution, just if it can put the next queen in any column, etc, etc. It's a complicated problem, to be honest. I pretty much did a really bad job explaining this, so yeah, that's about it. So that's how it works. It's gonna keep doing this at the end. Yeah, did not return the list of solutions. List of solutions. So for example, if it finds a solution in column 2, it's still gonna loop and continue. It's gonna return for the solution when it reaches 5, for if we have n equals to 4, and then it's gonna check position 2, and then it's gonna check position 3. So list of solutions. Okay, so it pretty much checks everything. Okay, and these help us to avoid checking conditions that we don't want to check. For example, if I remove this, I think we're gonna have hold on, we're gonna check together. I forgot, I think we'll have a time limit exception or something like push back. So push back the chessboard, pretty much. We're just push into the chessboard, into the list of solutions. And here I think we're gonna have, yeah, I think this is inside the solution, so we're gonna have backtrack of 0. We're gonna start from row 0 at column 0, and we're gonna return the list, which is the global variable of solutions. Alright, let's run this. Hopefully it works. Because I did this like a couple of days ago. Okay, I've always this problem with C, good gods, or C++. Okay, I need to remove these. I don't know, it sees like this empty space, it thinks it's some kind of variable, I don't know. I never had these problems in Visual Studio. It's weird, really weird stuff. Okay, white space, yeah, it calls that white space. What is this? What is going on here? Again, white space. Let's check again. Okay, if r equals to n. Oh, this again. All right. Sorry about this, guys. Just LeetCode being bad. at what it does. So what is this? Taken columns. Oh, it takens columns, doesn't it? It's taken columns. Okay. You know what? Let's remove this S. Just a typo. Alright. I think it's gonna work now. Okay, another error. Undeclared identifier C. Ooh, I forgot to put this inside the for loop. Okay, now it is inside the for loop. Okay, let's debug this together. What else? Okay, I forgot the semicolon. Alright, what else? Expected. Alright, what is this? What is this? Hold on, is this the... No, what is this? This is the function. So what do I need here actually? Oh, I forgot this. Okay, we need to put a semicolon after. Like, this is why Python is better in these like program. Okay, it works as you can see, and n equals to 4. We should submit that. It's gonna give us, I think, a good solution. In Python, we don't have semicolons and all of that. No, it's 25 milliseconds. It's not the best, but it works. You know, it's understandable, short, concise. And yeah, that's about it. Yeah, let's see together what happens, because I checked this in Python. I did a solution in Python. We remove this, it's going to be much longer. It's going to take so much more time. Alright, let's check together. Yeah, I think it's going to be a time exception. Or wrong answer, yeah. It's pretty much never going to stop. Wrong answer. Yeah, as you can see, we need that, because it's just gonna keep going on and on and on and on. It's never gonna stop. Yeah. So yeah, that's about it. I hope the video was informative. This is the code. Like, let me show you the full code. Let me make the screen bigger here. Hold on. The code shown. Okay, this is the code. It's a pretty complicated problem. Yeah. This is if out of bounds means we found a solution path. Yeah, that's about it. So see you next time in the next video, guys. Have a great day.